A few years ago, I was part of a team launching a high-volume pricing engine. We had spent weeks on the architecture. The load tests were perfect, the edge cases were covered, and the code was clean. On launch day, we watched the dashboards. For the first 6 hours, everything was green, transactions were flowing, and the system was lightning fast. Then, around 4 p.m., a single customer support ticket came in. A user in a specific region noticed their checkout price was $0. We laughed it off at first, assuming it was a browser caching issue, but then another ticket arrived, then 10, then 100. We pulled the logs, but here's the problem: there were no errors. No crashes, no timeouts, no 500 internals. According to the machine, the system was performing perfectly. We spent the next 3 hours in a war room, digging through layers of microservices. We checked the database, the API gateway, and the third-party integrations. Everything looked pristine. It wasn't until we reached a tiny 10-line utility function in the core pricing module that the room went silent. There was an if statement designed to handle special loyalty discounts. It looked like this: if user is loyalty member and promotion is valid. On the surface, it was perfect logic. But during a midday database sync, a specific set of promotion codes had been updated with a null expiration date. In our code, null was being interpreted as valid. Because we had prioritized clean, concise code, we hadn't explicitly checked for the null state. The system wasn't breaking. It was doing exactly what we told it to do. It was successfully and efficiently giving away our product for free. This is the anthropology of technical overconfidence. We often build systems based on how we think data will behave rather than how it actually does. We perform engineering by making our code look elegant and readable, but we forget that elegance is a liability if it hides a lack of defensive depth. In that moment, we weren't product engineers. We were just coders who trusted a variable. A product engineer assumes the environment is hostile. They don't just ask, does this logic work? They ask, how does this logic fail when the data is garbage? They understand that a silent success can be more catastrophic than a loud failure. A crash is a signal, a $0 price tag is a quiet bleed. This brings us to the clarity moment. The human impact of this invisible trap is the erosion of trust. When a system crashes, users get annoyed, but they understand tech breaks. When a system quietly lies to them or to the business, that trust disappears. Professional maturity is realizing that your job isn't to write code that works. It's to write code that is impossible to misunderstand. Clarity isn't just about how the code looks on the screen, it's about how it behaves when the lights go out and the data turns messy. So here's my question. Is your code elegant because it's simple, or is it elegant because it's hiding a ghost you haven't met yet? Let's stop trusting the if and start testing the else. Let's get clear. See you in the next one.